Hi, I'm Temitope Adiniji, and you are welcome to Organotope Chem Clinic, where chemistry becomes crystal clear. In this video, we'll be talking homologous series. What is homologous series? Numerous organic compounds exist in series or family called homologous series. So we can define homologous series as the family of organic compounds which follows a regular structural pattern in which each successive members differs from the next by a CH₂ group or 14 relative molecular mass units. How did we arrive at this? Each successive member differs from the next by a CH₂ group. The CH₂ group contains carbon, which has the atomic mass 12, and hydrogen with atomic mass 1 times 2. Therefore, we have 2 here and 12. 12 plus 2 will give us what? 14. So that is how we arrive at the relative molecular mass unit of 14. Therefore, successive members in the same series differ from the next by a CH₂ group or relative molecular mass unit of 14. This will now lead us to the characteristics of homologous series. But bear in mind that the simplest series of the organic family is the alkane series, which has the first member as methane. So we can actually consider the characteristics of homologous series, and the first one is general formula. All members in the series can be represented with the same general formula. So we need to consider the following homologous series. The first one, I'll be taking the alkanes with the general formula CnH2n plus 2. We have the alkenes with the general formula CnH2n, the alkynes with the general formula CnH2n minus 2. We can move on to other organic compounds like the alkanoic acid with the general formula CnH2n plus 1 COOH. Okay? We can as well have the alkanol, which is the same thing as the alcohol, with the general formula CnH2n plus 1 OH. We can have the aldehyde or the alkana with the formula CnH2n plus 1 CHO. It is actually observed that they have something in common. CnH2n plus 1. CnH2n plus 1 shows which group? We have the alkyl group. Okay? With the formula or with the symbol HAR. That means that we can equally express the alkanoic acid, the alkanol, the alkana in this form. RCOOH, the alkyl group with the COOH. We have ROH, the alcohol, also known as the alkanol. We can also have RCHO, the aldehyde, also known as the alkana. So we can observe that the members of the same series, they exhibit what? The same general formula. So let's take, for instance, the alkane. They have the CN H2N plus 2. The first member of the alkane is the methane. We have CH4. How did we arrive at the molecular formula CH4? This implies that the value of N equals 1. That means from the general formula CN H2N plus 2, C1, so 1 is insignificant, so we don't need to express 1. H2 times 1, that's 2 plus 2, we have CH4. Okay, the next one being the ethane. The value of N equals 2. So we have C2, 2 times 2, we have 4 plus 2, that's 6. C2H6. So we can equally use this method to deduce the molecular formula of every members of the series. Then I said earlier that successive members differs from the next by a CH2 group or relative molecular mass unit of 14. Compare the methane with the ethane right here, methane and ethane. The difference in their carbon atom is 1. 2 minus 1, we have 1 carbon atom. The difference in their hydrogen atom is 2. 6 minus 4, we have H2. So members of the series differs by a CH2 group or relative molecular mass unit of 14. The next characteristics of the homologous series that we are going to take is difference between successive member of the series. Like I said earlier, the successive members differs from the next by a CH2 group or relative molecular mass unit of 14. So let's check that together. I explained using the alkane earlier, but this time around I'm going to consider another series, which is the alkene series. The alkene, they have the general formula CnH2n. So the first member of the alkene starts with the compound with two carbon, okay? Because we need to express the carbon to carbon double bond. So we cannot express carbon double bond just within a carbon and another atom. So it must be carbon and carbon. So the first member of the alkene is the ethene. Ethene has the general formula CnH2n, and its molecular formula will be S is 2 carbon. Okay, so we have to substitute 2 in place of N. We have C2H 2 times 2, that's 4. Okay, ethene is C2H4. The next member, I don't need to go through the general formula anymore. Just add CH2 group to the previous formula, which is C2H4. So we are going to have 1 carbon to this, that will be C3. 2 hydrogens to that, that will be H6. So the next member is what? C3H6, which is the propene. Can you do the next? Okay, feel free to attempt it. We have what? The next member, 1 carbon, that will be what? C4. 2 hydrogen, C4H what? 8. Okay, so the next member is what? Butane. Butane rather. With the molecular formula C4H8. So try the next. Go ahead and try the next. Okay, what do we have? All right, that's right. We have what? C5H10. Okay, so members differ from the next by a what? CH2 group or relative molecular mass unit of 14. Okay, so the difference between this and this is what? CH2 difference. CH2 group what? Difference. So kindly take note of that. Successive members differ from the next by a CH2 group or relative molecular mass unit of 14. The next characteristic that we are going to take is the physical property. The physical properties of members in the same series shows a progressive change as the number of carbon atom per molecule increases. Like for instance, we have physical properties which include the boiling points. What do we observe in the case of the boiling points of members of the series? We have, for instance, carbon 1 to carbon 4 of an alkane. For an alkane, carbon 1 to carbon 4, they are said to be gases at room temperature. That is, the ethane, the propane, the butane, the methane, they are all gases at room temperature. So we have gases at room temperature. The carbon 5 to carbon 17 of the alkane, they are volatile liquids. Okay, carbon 18 of the alkane above, okay, they are waxy solids. So we've been able to consider the state of the alkane as the number of carbon atom per molecule increases. Carbon 1 to carbon 4, they are gases at room temperature. Alkane, carbon 5 to carbon 17, they are volatile liquids. So here we have gaseous states, liquid states, and we have the solid states of what? The alkane. The next property is the melting points. Melting points. The melting points of the alkane also increases down the series. Okay, that is from the methane down to decane to icosane. Okay, the melting points also increases. The next is solubility. Solubility is their dissolution in a certain solvent, which decreases down the series. That is, the lower alkane is said to be more soluble than the higher alkane. The lower alkane, being the gaseous state of the alkane, they tend to dissolve easily, or they tend to undergo dissolution easily compared to the liquid, and solid take time to dissolve. So dissolution or their solubility in certain solvents tends to decrease down the series. Go ahead and group the following alkane that I'm going to list on the board into their respective states of matter. Okay? C2H6, C18, H 2 times 18, that's 36 plus 2, that's 38. C5H 2 times 5, that's 10 plus 2, we have 12. C14, 2 times 14 is 28 plus 2, we have 30. C3, 3 times 2 is 6, plus 2, we have 8. So I would like you to pause the video and group the alkanes listed right here into their respective states of matter: solid, liquid, and gas. Okay, we have solid, liquid, and gas. C2H6. C2H6 is within this region, C1 to C4. That implies that it is a gaseous alkane. So we have gas. C2H6 is in its gaseous state. C18H38. C18, carbon 18 above, they are solid alkane. Okay, so we have it C18H38 is a solid alkane. C5H12, carbon 5 to carbon 17, they are what? Volatile liquids. That implies that C5H12 is in its liquid state. C5H12 is a liquid alkane. The next one, C14H30. C14H30 falls within the range of C5H17. C14H30 will be what? It is a liquid. So liquid alkane, C14H30 is a liquid alkane. Okay. C3H8 falls within the range of what? C1 to C4, which is what? Yes, it is a gaseous what? Alkane. Gaseous what? Alkane. So we have been able to group the alkane into their states: solid, liquid, and gas. Okay, so we have them right here. Moving on to the next, members of the same series may be prepared using similar methods. The method used in the preparation of alkene, the ethene, is similar to that of propene, similar to that of butene. Okay, so they have similar method of preparation, provided they are found in the same what? Homologous series. Like for instance, we have the preparation of alkene from alkanol. What method do we use in the preparation of alkene from alkanol, or the preparation of alkene from alcohol? We can carry out the dehydration of the alkanol. Okay, dehydration has to do with the removal of water from alcohol. We can observe that from the... So how is alkene formed from this? Okay, we have this to be ethanol, and here is ethene. So the transformation of ethanol to ethene is by the dehydration process. Okay, and the condition for dehydration of alcohol, removal of water from alcohol, is in the presence of concentrated tetraoxosulfate 6 acid. Okay, at 170 degrees Celsius. So by the time we get to reaction processes or reaction type, we talk more on this. So the process is dehydration of alcohol. So we've been able to form ethene. Similarly, we have the dehydration of the third member of the alcohol, which is the propanol. Keep in mind the tetravalency of carbon to ensure that you have 4 bonds around carbon, hydrogen, hydrogen. And here we have the functional group OH. So I will still talk about the identification of functional group in the presence of conc H2SO4. At 170 degrees Celsius, we have the formation of the products, which is carbon, carbon, carbon. So right here we have elimination of water. Hydrogen and OH forms the H2O. So there will be generation of what? A double bond at this point. We have hydrogen, 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 hydrogen. Okay? So I've been able to ensure the tetravalency of carbon. 1, 2, 3, 4. 4 bonds around carbon. So this compound right here is propanol. Okay, or propan1-or. And the compound right here is propene. Okay, the ethene and propene, they are in the same homologous series, while ethanol and propanol are also found in the same homologous series. So ethanol is being the ethene is being prepared using the same what method, which is what? Dehydration to form ethene, while propene is prepared from propanol by what? Dehydration as well. So they have similar method of what? Preparation. Moving on to the next characteristics of members in the same homologous series, we have they exhibit similar chemical properties. That is, they undergo similar reaction. When we consider the reaction right here, ethanol undergoes reaction to give what? Ethene. And what reaction is that? We have dehydration of alcohol, which is similar to the member of this alcohol homologous series, which is propanol. Okay, so they also undergo what? Similar reaction. Also, members of the same series, they exhibit what? Same functional group. They have the same functional group. Now let's check ethanol and propanol. They are in the same series. What is their functional group? The functional group in ethanol right here is OH, while the functional group in propanol here is OH as well, which is the hydroxyl group. When we consider the functional group in the ethene right here, we have the double bond. Double bond is the functionality here, while in the propene we also have a double bond there. In summary, we've been able to consider the characteristics of members in the same homologous series. We talked about their general formula. They have the same general formula. Number 2, each successive member differs from the next by a CH2 group or relative molecular mass unit of 14. We also talk about the physical properties of members in the same series. Their physical properties changes progressively as the number of carbon atoms per molecule increases down the series. We talked about the chemical properties of members in the same series. They have similar chemical properties. We also consider the functional group. They exhibit the same functional group. Then their method of preparation, they are prepared using similar methods. If you find this episode of the Introduction to Organic Chemistry interesting, kindly click the subscribe button and share with your friends right now. You can also like and follow my Facebook page. Thanks for watching.